right, lots of PA1, PA4 questions. So questions, PA4 or otherwise? Yes?
I'm having an issue with my save phrase function, and I'm like trying to pass the count array to it, and it seems like the count array gets bumped up in the function, but then when it comes out of the function and back to main, it's like that didn't happen. But
the count array or the dictionary length?
The count array. So like if it finds another of the same phrase.
So that should pretty directly go through.
It's really weird too, like it happens like on the first occurrence, but then on the next occurrence it doesn't happen. So like when I like pass like 5 or 6 phrases to it, the count array will be like 1 0 1 0. It's almost like every other. It's really weird. I was like going through GDB and it was
Okay. I'm gonna guess that's something different from what you think.
okay.
But let me ask you, in your save phrase function, if you find, so you got a phrase, you go through your dictionary and look for it. If you don't find it in there, right, you increment the dictionary length,
Yeah.
and then you save it in the correct spot in the dictionary, and you set the corresponding count element to 1, right?
Correct, yeah.
Okay, where's the dictionary length? Is that a global, or are you passing it to your function?
Passing it to my function.
Okay, are you passing it as an integer?
Yes.
Okay, and then you increment it inside the function?
Well, so when I did at first, and then it seemed like it was having the same issue where like it would bump it inside the function, then when it come out to main.
Right, right.
So then I took it out of the function and put it in the main. So if my function returns a 1, that means that it wasn't in the dictionary. So then in main it'll bump up the dictionary.
Okay, good. Yeah, because if you pass it as an integer, it won't affect it in main when you update it in the function because it's passed by value. But an array, if you have an integer count bracket 1,000, that should definitely be updating.
Okay.
So here's my first suggestion. Inside your save function, before you exit that function, print out, I don't know, the first 10 elements of your count array, right, with a message saying, you know, I'm about to exit my save function, here's what count looks like. And then in your main program, well, just do that.
Okay.
And make sure that on the way out of the function, the elements in the count array have actually been updated. Because assuming that you know, something like that, and then inside main, have a count array declared. And pass that just by the name count to the save phrase.
So when I did it like that, it kept like not finding that. Like through GDB, it would say that count was just 0x00. So I had to like, let me see how it is in my main. When I make the call to the function, I have it as address of count bracket I.
Oh.
Because
Okay.
every time I had it as just count, I was getting like a compiler warning saying like makes integer point from cast or something, whatever that is.
And count's declared as just an int 1,000?
Yeah, int count 1,000.
Shouldn't give you a so how exactly is it declared in the save phrase function? Is it integer count 1,000?
Yes. Yeah.
Should not give you a complaint about just using count. But if you do this, you're actually passing a truncated version of your array. If I is 5, you're passing the array starting with element 5. And in your save phrase, what it thinks is count bracket 0 is actually count bracket 5.
Oh, weird.
And yeah, that's going to be really strange in the way it manifests.
Okay.
So this would be the same thing as just passing count,
Okay.
right? But really, just the word count with no other embellishment should be exactly the same as this. And if it's complaining, show me that. Can you get it back to where it's complaining if you just say count?
Yeah, I can try and play around.
Show that to me in between the sections, and let's figure that out. But you could try just changing that I to a 0 for really quick.
And leave the ampersand?
And leave the ampersand, yeah, because the word count actually means the address of count bracket 0.
Okay.
Right?
Okay.
So you could try that, but then yeah, show it to me after class if you want.
Okay, thanks.
Mm-hmm. All right, more questions?
I had an issue with string copy.
Okay.
So I was able to, my code runs fine.
Mm-hmm.
When a phrase doesn't overflow, but when it overflows, I can track all the way through the code. I found the exact line that's causing the problem, and I still don't understand why it's causing the problem. But essentially, I store the phrase as just a str, and then I check that phrase later to see if it's appeared before, and if it hasn't appeared, then I actually add it to my dictionary.
Okay.
Which works fine, but if that string happens to be overflown, still stores it fine. It goes to the next iteration and just stores a shorter string, and it will store that just fine, and it will do one other thing. It will concatenate that on the end of the previous one.
Right.
And I'm not sure why.
So what do you mean by overflows? You mean more than 200 characters?
Yes.
So you got to be careful. Okay, so here's our dictionary. It's 1000 by 201. So if your first phrase is hello, it's stored hello and a null terminator and a bunch of other stuff, right, until you've got 201 bytes. And if your next phrase is cat with a null terminator, then there's other stuff out to 201 characters and so on. If you have a phrase that's longer than 200 characters, right, my long phrase is very long. If it's actually a lot longer than 200 characters, right, it'll just fall into the next spot in your dictionary. And if it's exactly 201 characters, so your 201st character is over here, the null terminator will get written in the beginning of the next spot in the dictionary.
Okay, because I'm manually adding a null terminator to the end.
Right.
And it works. That part actually of the code works. So there is a null terminator.
And it's at no more than position 200?
It's at 201.
Like phrase bracket 201?
Yes.
Okay, so if your thing can hold 201 characters, the last element in this string is bracket 200, because we start from 0.
That's my problem.
Yeah, so just back it up one spot. That should fix it. Edge cases are always tricky, and sometimes if I'm not feeling like working through it, sometimes I'll just go in and I'll just change this to like 205 and see if my code magically starts working. And if it does, then I'll change it to 202 and see if that makes it start working. And then if I change it to 201 and it breaks, that pretty certainly tells me I've got an edge case where I'm going one too far somewhere. And then I'll start looking at those sections of code more carefully. All right, other issues, discoveries. Yeah.
So I did have I was experiencing kind of a weird issue with my program where it seems to work almost perfectly, except like in War and Peace, I think there's supposed to be 259 instances of O, and I'm getting like 261. I'm guessing, I'm not sure what.
So I'm not going to worry about that.
Okay.
The version of index sample that I posted up on temp is from a few years ago when I did this, and I don't know if it actually matches exactly the specification.
Right.
So the sample file it works fine on, but it's probably an edge case either in your code or possibly in my code.
Okay.
My War and Peace test will be the following. I'll run your code on War and Peace. I would prefer it does not seg fault, okay? And I would prefer that it prints out, you know, about 1,000 phrases in increasing length with interesting numbers on the side, okay? I'm not going to check to see if, you know, this should have been 89 times and you only counted it 88 times or something like that. I'm really just kind of stress testing your code. And if it handles that stress, you get your 5 points for the War and Peace test, or whatever I said it was worth. I think it was 5 points. So yeah, I wouldn't worry about that too much. I lost my network connection. Hold on. So I posted some code from the other day into the shared area that you can get to on Canvas. And if you don't have Canvas access, it's just, well, should be able to do ~nix / public HTML / shared / 224. And that should be accessible. If not, let me know. But if you're on Canvas, it's in there also. So I posted something called Sample Phrase Builder. And this is a variation on some code that we were playing with last week, which was looking at this question of how do we use getCar to build a phrase. Okay, so first thing I want to point out, because I've seen this a few times. You can do this pretty much any way you like that works, okay? But here's the way that I've been trying to develop this code in class is a main program which basically does two things in a loop. It says read a phrase and then save a phrase. And it just keeps doing those two things. Read a phrase, save a phrase. Okay? So some people are trying to save their phrase inside their read phrase code. That makes things pretty complex. Right? Logically, these break out nicely. Read a phrase, which just gives me back an array containing one phrase. And then save phrase takes the dictionary, takes this one phrase, and either bumps up a tally or records this as a new phrase by adding it to the end of the dictionary. So keep doing this loop over and over and over until you hit the end of the file. And then sort your dictionary and print your dictionary. And those are pretty clean divisions of functionality, right? Sorting your dictionary is just doing your bubble sort on this two-dimensional array. And then printing is a for loop, go through and print each line along with the string length of the line. So really 4 pieces of code that your main program does, 2 of them in a loop until you try to read one more phrase and it says end of file, and then sort your dictionary and print your dictionary. Okay, so reading a phrase consists of basically find the start of the phrase, really does the following. Find the start of a phrase. Yes?
I would assume that rephrase starts after
So this is the call to super duper get car.
Oh.
Right, so that's super duper get car. So that gets called repeatedly inside this read phrase function. So main never calls super duper get car, okay? Main says read a phrase from the input, and that read phrase function calls super duper get car as many times as necessary. And remember, each time you call this, it ingests a character from the input. And once you call get car, the character that it ingested is basically gone. Okay, it's been consumed from the input. If you saved it in a variable, you can use that variable wherever you like, many times you like. But the next time you call get car, it's going to read the next character from the input. So it's kind of a one-shot function. So somehow you want to find the start of a phrase, right? So typically a phrase ended with a period, and then maybe there's a bunch of spaces, and then there's a new phrase and a comma and some spaces. And some spaces and so on. So let's say you just finished this prior phrase, you just read that period and you read everything before it. So the next time you call get car, you're going to see a space. Okay, that does not begin a phrase. A phrase begins with something that's not a space and not a period, comma, semicolon, colon, etc. So up here we're doing some kind of loop, skipping over things that don't mark the beginning of a phrase until we get to the first character of a phrase. Now we're in this sort of main loop of read phrase, which says get a character, save it in our output array. Get the next character, save it in our output array. Get the next character, that's the end of the phrase, right? Comma terminates the phrase. So kick out of this loop and now just write a null terminator in your array. So at this point, out is this 2-character string so, and you return that back to your main program. Now your main program says, I found a phrase, SO, let's save it in our dictionary. So save phrase searches your dictionary for that phrase. If it finds it, bump up the count. If it doesn't, add it to the end of the dictionary. And then go back to the top of read phrase. Well, read phrase is going to start with, this space, which is not the start of a phrase. There's a W, that's the start of a phrase, and it does the same thing. It'll consume we should go. That'll be your next phrase that it returns to main. So you may have already done this in a different way, and if it's working or close to working, keep going like that. But if you haven't gotten to this point yet, it's cleanest, I think, to have super duper get car called inside your read phrase, right? And super duper get car is really just, get car with some extra stuff. Get a character, if it's a double quote, get another character, and so on. And then convert it to uppercase, and if it's a white space, change it to a single space, and return that. So it's a hierarchy, right? Main calls read phrase, which calls super duper get car, which calls get car. And having that hierarchy is going to make your code cleaner and easier to work with and easier to develop probably than if you have calls to get car scattered in here and scattered in here, or even scattered inside your sort, right? So we're partitioning the problem into pieces. So this was a version of a get phrase function. We played with this last week. We were using $signs through the end of the phrase. So here's a slightly different version. This used to say while ch is not equal to $sign. Well, I modified it to say while ch is not a period or a comma or an exclamation mark. So what does this do? It calls get car. Think super duper get car. Okay, but it calls get car, finds the first character. If it's not the end of a phrase, save it into our output array, bump up the location, get another character, and come back to the top of the loop. If that's not the end of a phrase, save that, bump up the output location, get another character. So we keep doing this until we find one of these things that terminates the phrase. We save the null terminator, and we just return at that point. So in our main program, anytime that I say get phrase temp, temp should be the next phrase. Terminated by, I'll put the good code there. Terminated by a period, a comma, or an exclamation mark. So it's not exactly all of this. It's really this middle piece and a little bit of this end piece. It's not skipping the stuff before a phrase starts. Okay, but it's getting characters and it's adding it to the output until we find one of these three terminators in this case, and then it's adding the null terminator. So I made a sentences file which says, hello, this is a test, how are you? I'm shouting, yes I am, I am. And so if we run this on that file, the first phrase it found was hello. Why? Because that ended with a comma. The next phrase began immediately with a space, this is a test, and it didn't include the period, which is correct. The next phrase was space, how are you? Exclamation mark, right? And I'm not looking for the beginning of a phrase. I'm assuming as soon as one phrase ends, the next phrase begins with the next character. That's where I'm getting these spaces in the beginning. Okay, but this is successfully chunking up the input into things that, you know, end with a comma, a period, or an exclamation mark. Mm-hmm.
So if we don't use car ch, we use int ch, and we replace all the dots to the ASCII code, this still work, right?
So if we do, oh yeah. So this should be an int. Get car, you should always return an integer.
But it still work if it's not integer. If it's car.
It will still work unless you care about EOF, which I didn't care about in here, which was why I got a seg fault. But if you care about EOF, you got to be using an int, not a car.
Okay. So when you use int ch and in the while loop, in that part, so ch doesn't equal to, can I replace that dot to the ASCII code of dot?
You can, but it's better to just use a single quote dot single quote.
Okay.
But that's what that means, is the ASCII code of a dot.
Okay.
But it's easier to read like this and it's more portable. But yeah, it should do exactly the same thing. Okay. So does that make more sense? Right, because I'm finding a lot of people asking, like, okay, I've got super duper get car, but I don't know what to do with it. How do I link that into the phrases? This is one way to link it in, right? And like I said, it's not perfect because we also need to look for the start of a phrase in the beginning. But you know, the guts of this read phrase thing is really this middle loop, right? Get your cleaned up character, save it in your output array. Just keep doing that until you find the end of a phrase, and then set your null terminator. And to do this right, I would probably want to include EOF as an end of phrase. Otherwise, when I hit EOF, this loop runs forever, which is why it's seg faults. So I would probably want to also put in ch not equal to EOF. So this is a decent way to test your phrase reader, right? You can just make a main program that just calls get phrase 10 times and prints out the result each time. If you can read 10 phrases from an input, you can probably read War and Peace. Okay, because it's really just kind of doing the same thing. So you can write your phrase reader and you can test it with just some calls to get phrase, and make sure it prints out the right thing every time. Alright, so that's what it actually does on War and Peace. And you can see strange things happening, like my phrase started with a new line, right? So I should have turned new lines into spaces, and then I should have ignored spaces when I was looking for the start of a phrase. And this, no longer my faithful slave, that new line should have become a space, and then it would be coming out on one line and so on. So once you've done that, the other part of your main program is save phrase. If you can read and save, you're mostly done with the assignment. Okay? You definitely want to have a print, because when I run it, I need to see your output. If you don't get the sort working, I think that's like 10 points or something. It's not a deal breaker, right? But make sure you have a print, because if I run your program and it doesn't produce any output, it's really hard for me to grade it. And print is just a for loop. Right, for I equals 0, I less than dictionary length, print string length of dictionary I, and print dictionary I with a %s. So the real challenge is the read phrase and the save phrase. Okay, read phrase, hopefully you've got an idea on how do you save phrase. So you need to have the dictionary you're going to save into. You need to have the count array, because you need to record how many times you see a phrase. You need to know how many things are in these arrays. Right? We don't want to loop from 0 to 1,000, because we don't know if we actually have 1,000 phrases in here. And if we're trying to find a new phrase, maybe my dictionary just contains random stuff that says, you know, it's time for war to come to Genoa, and when I read that from War and Peace, it's going to say, oh, this is already in your dictionary, right? So we need to know how big these arrays actually are, how many of these entries, how many of these 1,000 entries actually are meaningful. So that's what something like dictionary length tells us. Initialize it to 0, bump it up each time you add a phrase. So for I equals 0 to dictionary length minus 1, if dictionary entry I is the same as phrase, right, and that's where you want to use string compare, strcmp, if dictionary I is the same as phrase, then our phrase is already in the dictionary at location I, so just increment count bracket I and return, you're done. Nothing else you have to do in here. So do this loop through all the entries in your dictionary, and if you come to the end, this is a new phrase, so add it to the end of your dictionary. So copy your phrase into dictionary bracket dictionary length. That's where you want to use string copy. Save your count as 1, and then increment your dictionary length. And if you pass dictionary length to this function, you got to make sure somehow that this new value of dictionary length gets passed back to your main program. So you can either pass this by reference, right, make it a pointer, or you could return a value from here, which is the new value of dictionary length. And then in your main program, you could set dictionary length equal to the return value. Or you can return a flag saying, did you find a new phrase? And if you do in your main program, you can increment dictionary length, right? But you gotta have some way to pass this action back up to your main. But that's basically your two options. Loop through your dictionary. If you find the phrase, bump up that count and return. Or if you loop through and you don't find the phrase, copy it into the next spot in your dictionary, set the count to 1, and return. That's really the essence of the whole save phrase. And then go back, read the next phrase, save that next phrase, and so on. And that gets you most of the way there. If you don't check to see if you're over 1,000 entries, right, your code will still work on a reasonable sized input. It'll segfault on War and Peace. But that's, you know, that's dotting the I's and crossing the T's, basically. So other questions about this? All right, so separate topic. How many people have a laptop that has some version of Linux on it? Meaning either you have a Mac or you have a Windows machine with Cygwin, or you have a laptop with Linux or something. Let me see a show of hands. Okay, cool. So PA5 is going to be a group project. And it's going to be something that you can't really do on the Linux server. It's going to be something you need to do on a machine that's running Linux in some way, shape, or form. So, and it's a group project, so you get to work with other people, but I want to make sure there's enough people who have a machine that runs some version of Linux, so that if we have groups of, say, 3 or 4, everybody's going to be able to partner with someone who has a machine that'll do this. And I think we're good here. We'll see how the other section is. And PA5 is going to involve a little bit of doing graphics. We're going to make a graphical menu-based system. And that's hard to make work with Windows from the Linux server, unless you have some other software to run on Windows. So it's best done on an actual Linux install or Cygwin or something like that. So we'll go through details of that tomorrow. We'll finish PA4 first. Any other questions on PA4? If you don't get it to the point where you feel like my running it is going to get you a good grade, right? You can put comments in your file, preferably in the very beginning of your main program, and or copy those into the submission comments on Canvas. No, we're not doing Canvas, never mind. Put them in your file, or put them in a README, even better, and let me know where you stand, right? If you say something like, my phrase reader seems to be working, here's my test program I used for it, right? But I couldn't get them to store in the dictionary. At least I can run your test program, and I can, you know, see if that part of your code is working, and that gets you a bunch of points. Or, you know, you got everything working except when you wrote the bubble sort, it segfaults, right? Comment out the bubble sort so that your code doesn't segfault, and put a README in there and say, you know, everything works great except it's not sorting. When I do this bubble sort, it segfaults, so I commented it out, but I left the code in there as a comment, right? And then I can look at the code and maybe give you partial credit for the sort and so on. But, you know, I grade these things myself. They're not automatically graded in any way, shape, or form. So, so you're welcome and encouraged to leave me a README if things aren't, you know, the way that you want them to be assessed. You can let me know where you are, what you ran into, but try to leave, you know, as much runnable stuff as possible, right? Even if it's not the whole assignment. If you have test code in particular, right? Leave that in place, make it so I can compile it and I know how to use it, and I'll work with that. Because the worst case is not turning anything in. The second worst case is if I just go through your code and I start trying to reverse engineer it and figure out how close you were. That's harder to do. And you might be very close with some very complex, convoluted code that's 99% of the way there, but I can't tell that from looking at the code. But if I can run it and see that it works, most of the way, then I can give you more credit for it and so on. So don't be afraid to communicate in there. And for GitLab submissions, just make a README, and I'll eyeball that. Yeah.
When my question is about EOF, when I manually enter text, the EOF doesn't register unless I do a new line. Then EOF. Is that just normally
That's
how
how
it
EOF
works?
works. Yeah, it's got to be a control D by itself at the beginning of a line.
Got it.
Otherwise, it forces your input into the standard in pipeline, but it doesn't actually register as anything.
Okay.
So yeah, anytime you want to use control D, always hit a new line first and then control D, so it's the first thing on the line. And if you redirect from a file, you don't have to do control D, because when you hit the end of the file, it'll get car will pick up EOF. All right, but we're going to go back to regular expressions unless there's more questions. So regular expressions, we started talking about, we had two anchors, a caret and a $sign. All right, so this is the first character. This is the last character. So beginning of line, ending of line. We had period, which matches any one character. We have a star, which matches 0 or more of the previous character. We can say things like bracket, A-E-I-O-U, which matches any of A, E, I, O, or U. And we can also do things like bracket A through Z, or bracket 0 through 9, and so on if we want to express a range of things. And this will match anything between A and Z, or anything between 0 and 9, and so on and so forth. And we can also do bracket caret stuff matches anything except stuff. And these are just quirky ways that we can talk to something that understands regular expressions and look for patterns in, say, a file or a string. If we want to match 3 characters, we can just search for ... If we want to find 3 characters at the beginning of a string, we can say caret ... And if we want to find 1 character followed by a vowel, we could search for a period followed by bracket A-E-I-O-U. So let's just pick on War and Peace, since that's our favorite topic. Those are all single lines. So if we want to look for an uppercase letter, right, I could say slash, which is a search, bracket A-Z. And that'll take me to an uppercase letter. There's an H, and I'm using N to search for next occurrences. So if I hit N, it takes me to the W, and then the Prince, and then Genoa, and Lucca, and so on. If I want to search for for two-letter words that start with an uppercase character, right, I could search for an uppercase letter followed by a period, which is any character, followed by anything which is not the letter A through Z. I'm not positive this will work, but let's see. So it takes me to the word it, and it takes me to the word saint, and if, and so on. All right. So my pattern was anything between A and Z, that's an uppercase letter, followed by any character at all, followed by anything other than a lowercase a through Z, which is a rough script for saying give me a two-letter word that starts with a capital. Not perfect, but it's an example. And if I wanted three-letter words that started with a capital, I could try this. This will be even less perfect. But it's an uppercase letter followed by any two things, followed by something that's not an uppercase letter. So it found set and can and so on. If I want to find two uppercase letters in a row, this should do it. AZ, AZ. I don't know if there are any. Yeah, so CH and PT, and 2, and Louis the 15th. So these are versions of wild cards, okay, but more powerful than just saying a star that matches, you know, a bunch of text. We can pick individual characters, successions of characters, characters within certain ranges or outside of certain ranges, and we can anchor these things. I wish I knew where my names file was, but I don't.
George Jetson.
Thank you. No, that's gonna mess me up. All right, so there's some names. So let's say I want to change this from first name, last name to first initial, last name. So I want to change this to J space Smith, B space Rubble, and so on. So regular expressions let us do this. So John Smith. So there's two things we're going to do. First, we're going to look for something inside this string, and then we're going to replace it with something else. So if I want to change John Smith into J Smith, what I really want to do is find everything after that first initial up to that first space and replace it with just nothing. So I need to figure out a regular expression that will match this piece of the input, this piece of the string. So something like caret for the beginning of the string, and then a single character which will match that first letter, and then 0 or more additional characters, followed by a space. So if I search for a period, period, star, space, that should match my first name, John in this case. Right, so that brings me down to Barney. If I search again, it'll take me to Betty and Fred and George and John and so on. So if I wanted to completely get rid of the first name, I could do the following. 1 comma $, substitute caret, period, period, star, space with nothing. Okay, beginning of the line, any letter followed by a succession of characters followed by a space gets replaced by nothing. And that should just clear out the first names and leave me with the last names. So getting rid of stuff is pretty straightforward, right? Find a pattern and just replace it with nothing. Or maybe replace it with something else like first name followed by a space. So that's half of what we do with regular expressions. We find patterns, we can replace them with something. But what we really want to do is not replace the entire pattern that we matched. We really just want to replace this part of the pattern that we matched. So it's this period star, this collection of characters after the first character and before the space that we want to replace with nothing. So we're over time, but I'll give you a heads up. What we're going to do is we're going to take this thing that matches the period and we're going to save it somewhere. And then we're going to replace all of this with just the thing that we saved. And that'll change John Smith into J. Smith, for example. And it's going to be something like that. And the parentheses around that dot will say take that dot and save it into something we call register 1, and the \1 will say replace it with the contents of register 1, and that'll do what we need. So we'll talk about what these registers mean tomorrow after we're done talking about PA4 and PA5, or maybe next week. All right, so I'll see you tomorrow.